Hello everyone, my name is Even Xu. You can also call me Leon. Today I'm here to present my machine learning model about using random forest model to predict individual's gender. Let's start it. First, before everything is started, I wanted to introduce a concept to everyone. Maybe some of you audience already heard about it, but some of you may not. This concept is called the Internet of Things. The Internet of Things means there is a house full of electronic device, and all of those devices are linked to your cell phone, which you are able to control it using your voice. In order for this to be complete, the machine should be able to recognize individual's voice. That's how it receives commands, and it knows that you are the owner of the device. So, the model here that I'm presenting today will not be able to accomplish that yet. But I believe with the further on technology development, one day it can predict individuals' voice and know exactly who they are. However, today, the prediction model I provide can only predict individuals' gender based on the variables we feed to it. Just now, I want to introduce to our datasets. Here are some institutions that help collect the data I got for the datasets. They are the Harvard Hoskins Database of Regular Time Speech, the Telecommunication and Signal Processing Laboratory, the Vox4 Speech Corpus, and the FastVax CMU RTAC Speech Database of Carnegie Mellon University. Thanks for the following institution thanks for their sharing that I'm able to collect those frequency of the voice to use on my data analysis. And now, here are all the variable names that we can see in our datasets. The first one is the duration, which is the length of a signal. As you can see, our voice can be seen as a kind of signal that's being received by the machines. The length of the signal actually usually depends on how long we are speaking. And following up is the main frequency, which is the frequency that we speak. After the main frequency, there are a couple descriptive analysis value that's used to analysis the frequency that we speak. They are first the standard deviation of the frequency, the median, which is the median of the frequency, the Q25 and Q75, which is the first quantile. This means the middle number from the lowest frequency to the middle frequency, and the Q75, the third frequency, which is the middle value from the middle frequency to the maximum frequency. And then after that, we have the IQR, the SKEW, and the Kurt values. The IQR is the interquantile range of the frequency. The skull is skullness, and the crosses are all important variable about distributions. They are variables used to describe the distributions of certain plot. In this case, it's the frequency. And then after these variables, we got SPENT, which is the spectral entropy, and SFM, which is the spectral flatness. Both of them are for the spectrals, which is an important aspect about people's voice. After that, we have mode, which is mode frequency. This part is about voice vibrations frequency. As we all know, that vibration is also a really important part about how we make noise. And then following up, we got the central, which is the frequency central. This is also related to the frequency of the vibration. And follow up, we have the main fun, the minimum fun, the max fun, which is the three kinds of value about the fundamental frequency, related to a cross acoustic signal. And then we got mean doom, the minimum doom, the maximum doom, which are the dominant frequency related to a cross acoustic signal. And of all of these variables, we got the deep range, which is the range of dominant frequency measured across acoustic signals. And at last, we got ourselves a mode index, which is a calculated variable based on accumulated absolute difference between adjacent measurements. Now, let's move on to our next slide, which is our dependent variables and predictors I have. So this slide is actually a summary about all the information we got. The dependent variable, obviously, is going to be a label, which is going to show us if either the output is going to be a male or a female. And then the predictors. All of these are the variables that I list above. Apparently, I'm not going to use all of them in both of my methods. I'm just going to pick the one that is most relevant to the label, which means our dependent variables. So let's get started. The first step is ask us to do a descriptive analysis for all the variables I got. I know that some of my variables are already descriptive analysis variable, but one thing to recognize is that they are actually the descriptive analysis value about the frequency people speak. They are not the descriptive analysis variable about the data sets that I'm decided to use to test. So therefore, I still have the reason to run a summary about my datasets to see the median, the mean, the maximum, and the minimum value about all these variables. Besides all of these, I also test their standard deviations. As you can see, right now they are listed left and right on the slides. I also did some plots to make the variables visualized. I tried the density here. As these are only a few density graphs I got, I did all of them, but obviously this slides cannot fit all of them, so I picked some of them. You can see that for some variables, the densities are floating all around the chart. They are pretty average from 0 to 0.8. And for some of them, they have a peak value, and some of them are really low, some of them are really high. These are all just to bring a further understand about our variables. Besides our density, I also did a histogram of all these variables. I picked some of those histograms on the screens to make visualized. These are frequency, and these are the things I choose to see how the distribution of the data. So right now we already know a bit more about all the variables we have. We visualize it. We know the standard deviation, the mean value, and all kinds of things. So it's time for us to actually define our classification problem and identify the predictors and our dependent variables. First, what I want to do is to have our classification problem, which is going to be, will machine be able to predict individual's gender using some of above predictors? I said, just like I said above, our dependent variable is going to be the label. This label is going to be sorry of that. This label is going to be either a male or female. And then I choose my predictors, which are the mean frequency, the SD, the SFM, the IQR, the mode, and the deep range. Next, I am going to explain why I choose these as my predictors. Here are the reasons why I'm choosing these variables. The first is the mean frequency. the main frequency is the very basic unit for every voice. In order to test this voice, all of the main frequency is sufficient. Without these variables, our data will be meaningless. So, all of this are necessary under any circumstances. Following up is going to be my SD and IQR. I know there are a lot of descriptive analysis variables inside that datasets, and standard deviation score and IQR are the one that I think is the most relevant to the main frequency. That's why I picked two of them to represent in my model. Following up is the SFM, which is the spectral flatness. I believe they can represent the spectral flatness is more important than the other one. That's why I decided to include this into the model. Following up is the mode, which is about vibration. Since vibration is an important aspect about how people make sound, I decide to include that as a part of my model. And finally, my final decision is about differing, which is the range of dominant frequency. I believe the select of diff range is able to include it all about range, all about both dominant frequency or the introduction frequency. After after introduction of these variables, let's move on to the next slides. The next is going to be the classification model used to solve the problem. I'm going to go over all the codes I used. First is the voice. The first line, basically I just divided all the data sets into 80% and 20%. The first 80% used to train the voice, and the next 20% used to test it. And before I build a model, I have to translate my label into a character and a factor. That is the only way it's going to function normally for my model. Moving on, we have model using rainforest. We use our dependent variable label here, and all of those predictors follows. And we got our predictions here, and then finally we got our accuracy. And the following three graphs are the output of model, prediction, and accuracy. We can see after we go over the model, it gave us some pretty useful information here. And then we got our prediction model, which if this is a little blurry, but you can see the female and males on the chart, which is the expected output we want to see. And then finally, we can see our accuracy score, a 95. Well, it's a pretty high one. Then we move on to our step 3, which is to build a baseline model with similar number of predictors and compare the performance of the baseline model with that of a model from step 2. And we should compare the accuracy for both two models. The models I pick as the baseline model I picked here is really similar to the one that I did above. Since it's also used the rainforest the rainforest method, the first couple steps are exactly the same, and here is the only part I changed. Besides using all of those variables, I only picked these three. The first is the main frequency, which just like I explained above, is the most sufficient one that every prediction model should have. And then I select the mode to including all of those things. As you can see, I left out all the descriptive analysis variables. I only picked the model. I think it should represent an aspect about vibration, which is also related to the voice, and the diff range, which is another important aspect used to detect the range of certain frequency. These are the three variables I think that must be included in a baseline model. And after I go over the model, the prediction, and the accuracy, just like the above model, I got a result here, but if we look the accuracy score here, this is only a 87% accuracy. Well, in order to compare them, I decided to run a couple rounds of data to see if it actually works. So, in order to compare the results, I set the number of iterations into 100 and created 2A's history to record all of those numbers. And then inside this for loop, I divide my data into 80% and 20%. And just like the above, I transfer my label into character and factor. And then I set up my model. Model 1, the baseline model. The model 2 is the model I set up for the prediction. The next is basically the same, the prediction, the accuracy score. And after I output my ACE history, we can see that the baseline model already has a 97% of accuracy, and my enhanced one has almost 100%. It has a 99%, almost 100% accuracy about the predictions. I also did a plot and a t-test to help visualize all the informations. We can see that my enhanced model has a significant more accuracy than the baseline model, although there's only 0.02% of accuracy. From this model, we can see that machine is able to predict people's voice based on only a few variables. Since the baseline model already have a 97%, I say that with a mean frequency, vibration value, and the range of certain frequency is sufficient enough to predict if a people's voice is from a male or a female. However, after a reconsideration about the entire environment of the data sets and apply it to the real life situation, I realized that in a real life there will be more variables. What if there are two people talking? How is machine able to separate different soundtrack? What if people's voice get mixed up with background music or surrounding noise? What if I want to give up my order in a rainy day, or if it's have a storm outside? Are a machine able to divide a different soundtrack? Well, I believe that the voice frequency of all data I collected are recorded in a quiet room. Even though they are collected from all those universities and laboratories, I believe they collected in a quiet room when they speak to the machines. In order to avoid that situation, I think more real-life data should be included more information, which included like maybe different sounds mixed up together, or some sounds about rainy, or even maybe a weather information, or maybe even a traffic information. I just believe if I add more sounds into this data set, I will be able to predict individuals' voice about whether they are a male or a female with a more accuracy. I know this is only a few steps about depending people's voice from their gender to see if they are male or a female, but I do believe that with a development of machine learning, eventually, a machine is able to pinpoint every voice. They are able to divide a different soundtrack, and they are able to recognize who's their owner and who's not. That's the end of my presentation. Thanks everybody for watching it.